Picture a midweek morning. Tenants call the front desk. Lobby's warm. Staff assume it's just a fluke. 3 days later, several suites lose conditioned air. A stuck actuator and a failing pump have already cost days of productivity. How would you have known earlier on a modest data budget?
Welcome to Built, Wired, and Secured. I'm Alex Morgan. Today, we're talking baseline telemetry, the few simple signals that tell you a system is drifting before tenants call. Joining me are Michael Harrington and James Rogers. Both have hands-on experience turning small data sets into fewer surprises. Michael, James, thanks for being here.
Thanks, Alex. Glad to be here. From an operational standpoint, the thing I see most is teams reacting to tenant pain instead of catching slow degradations. You need repeatable, reliable signals that scream, "Look here," before it becomes a customer problem.
Right. Those signals don't have to be fancy. Reliability starts with disciplined maintenance and a handful of measurements you actually check. A valve that used to close in 2 seconds and now takes 8? That's not a statistic. It's a symptom waiting to become an outage.
Wait, 2 seconds to 8 seconds? That kind of change sounds small on paper, but huge in practice.
Exactly. You catch that early and you avoid emergency parts orders and weekend labor. Trust the process. Small signals, disciplined checks, documented fixes.
Michael, when you talk about costs, what's showing up first in the ledger? Tenant complaints? Overtime? Both?
All of the above. Tenant complaints are the visible tip. Under the surface, you get rushed replacement parts, untracked temporary fixes, and a maintenance backlog. So I ask teams, what breaks if this goes down? That forces priorities for which assets need baseline signals first.
Good question to center decisions on. James, where do blind spots usually come from in real buildings?
Legacy BAS points, siloed ownership, and a maintenance cadence tuned for scheduled checks instead of drift. Installers hand off systems. Nobody tightens the measurement list, and years later you find you never collected the signal that would have warned you.
So what are the right minimal signals? Power? Valve times? Door states? Network checks?
Start with 3 to 5. Power draw on critical pumps and fans, actuator or valve travel time, contact states for key doors or dampers, and a synthetic BAS availability check. Together, those cover mechanical, control, and connectivity with low data volume.
Sampling cadence is the next big decision. Too slow and you miss trends. Too fast and your team drowns in noise and costs. For many assets, a 5 to 15-minute aggregated cadence reveals drift without overwhelming storage or staff. But
I'm not sure I buy 5 minutes for critical pumps. If a pump is starting to fail, seconds matter, right?
fair. If you have 24/7 response and the downstream systems require it, finer telemetry makes sense. But most owners can't staff around the clock. High-frequency alerts without the ability to act just create fatigue. That's fine until it fails.
Here's the compromise we use. Keep 5-minute rolling trends as the default. And for assets you tag high risk, maintain a short high-resolution buffer, maybe 10 minutes at a 1 second or 1 sample per 5-second rate. That gives you context around incidents without permanent high-cost storage.
Nice. Trends for general monitoring, short high-res windows for forensics, practical and budget-aware.
Curious. Ownership is the other trap. If facilities see power trends and IT sees network pings, nobody watches the intersection. Define who owns which alerts before you collect data. That prevents the blame game when something trips.
Shared responsibility, single playbook. Facilities interpret mechanical signals and set thresholds. IT manages transport, storage, and authentication. The playbook says who gets paid at 8 a.m., who covers weekends, and how to mark a false positive.
And vendor lock-in? Teams often get sold full-stack analytics before they know if telemetry even helps.
Don't commit to proprietary analytics for a pilot. Use vendor-agnostic sensors, open formats, and low-code dashboards. Prove operational value, fewer complaints, fewer emergency calls, before signing long contracts. In one campus, we cut emergency calls by 40% in the first quarter after a 3-signal pilot.
That's a compelling stat. Okay, give listeners a concrete pilot they can run this quarter without breaking the budget.
Pick 3 signals: power draw on a critical pump, actuator travel time on a recirc valve, and a synthetic HTTP fetch of the BAS front end. Use low-cost power clamps and travel time sensors. Route them to an edge aggregator that stores rolling hourly averages plus a short high-res buffer, and build a simple dashboard. Run it for 30 days and log every alert as actionable or noise.
And pair that pilot with a 1-page playbook: who investigates, what measurements to capture during validation, and how to tag false positives. Tune thresholds conservatively at first and tighten as you learn.
I love the conservative tuning rule. Keeps people from chasing ghosts. A quick question on retention. Some owners want to keep everything forever. Thoughts?
Keep it practical. Store aggregated trends longer and keep high resolution only around incidents. Define governance upfront. Anonymize anything that could touch tenant data, restrict access, and align retention to maintenance cycles. You'll save money and reduce compliance headaches.
And document every tuning decision. If you change a threshold, write why. That trail is gold when you review what worked in a 30-day validation.
All right. Before we go, give listeners 3 quick, actionable steps they can take this week. James?
1. Pick 3 signals tied to tenant impact. 2. Assign ownership and write a 1-page escalation playbook. 3. Run a 30-day validation and label each alert actionable or noise. That cadence will tell you fast whether telemetry is delivering value.
And add a gating rule for pilots. Use open formats and low-code dashboards. Measure operational impact and only scale when you can show reduced unplanned downtime or a clear ROI.
If you'd like a 1-page starter checklist and a 30-day validation template, download GDS Technologies Telemetry Starter Checklist. And if you experienced a recent surprise, send us 1 sentence about it. We'll pick a few to troubleshoot on future episodes. Built to last, wired with intention, secured for the real world.
Thanks for having us. Remember, ask what breaks if this goes down early, and you'll focus telemetry where it matters most.
And trust the process. Small, repeatable signals plus disciplined validation beat one-off projects every time. Start small, learn, and scale.
That wraps up today's episode of Built, Wired, and Secured. We talked minimal telemetry that helps teams find problems early and reduce surprise outages. Thanks for spending a few minutes with us. Until next time, make sure the systems you're responsible for are built to last, wired with intention, and secured for the real world.